All right, so components. The reason we would like you to understand components. Your rig is essentially a machine. So when we're looking at the basic power system for our rig, we understand that they have 12-volt batteries, correct? That means all of the circuitry and wiring for that rig are set up for 12 volt. That means when you push a button because you want something to turn on, it will use power from those batteries to give you what it is you're asking for. Now, right here, I've had people say, well, that thing's not 12 volt. That's air driven, and that's what we use to engage our pumps. Well, that's true, but the light there and the light there and the interlocks that get engaged to tell the rig don't go into drive anymore are all 12 volt. So even things that are air driven or mechanically driven, now these things are very complicated. They're all being watched by computers, by sensors, by modules, you name it. So even if you think mechanical, it's still got some electrical components. So we've got the command zone, we've got the shifter, we've got all these super cool lights, we got all these parts. Even though they're mechanical, they're still electrical in some way or another. Batteries. Further on in this thing, I'm going to show you guys what a corroded battery connection looks like. Some of the cool things about our modern stuff. We now use gel batteries. They don't have the same off-gassing problems that our old lead acids do. But our old lead acids are still in our vehicles. We don't put gel in everything. Some of the smaller vehicles, the DCs, rigs, and all that, they still have traditional batteries in them. All right, so over here I show you an AC compressor and an alternator. Why would I show you those? So, you're saying that the alternator down here is what charges the batteries. You are 100%. But why would I also show you the AC compressor? Because it uses an electric switch to engage it. So even though it has nothing to do with electrical, it still needs electrical to turn on and off. It also has an interlock built into it, so that if the pressure drops down in the AC system too far, it will not allow it to engage, so that it will not become damaged. So I've had actually people call me up at home and go, hey, can't get my AC to turn on. Can I pull the cover down off of the ceiling inside the cab and clean out the filters and make it work? Oh God, please don't. Please don't do that. You'll never get that cover back on. But did you check to make sure that the clutch on that AC compressor engages? Well, why would I do that? Because if the pressure has bled out, it will not allow that thing to engage. If that compressor does not engage, pulling all the covers off and cleaning all the filters aren't going to do you any good at all, other than get you really dirty and make a huge mess. And then you're going to have to call the shop and tell them, sorry, I did this thing that I shouldn't have done, and I need you to come help me put it back. That never goes well. Questions about any of that? All right, so what we're looking at here for your basic 12-volt systems, we've got battery, alternator, voltmeter, ammeter, and load manager. Why? Why do we have things there that maybe have names you don't understand or haven't heard before? Are there any names here you haven't heard before?
Yeah.
Which one?
The ammeter, the meter.
Beautiful.
Yeah.
And any other ones? Mike, you were going to put your hand up. I saw you. I saw you.
Ammeter.
Cool. That is short for amp meter. So, in water, we talk about pressure and GPM, correct? Electrical has very similar functions, but we say voltage and amperage, or current. The voltage is the pressure. So here's how I equate this. Can I have pressure without GPM? The big thing is, who says I didn't turn on the water, charge the line, and then shut off the source? Is the pressure still there? Yes, it is. But the second I open up that nozzle, it just dumps out and there's nothing behind it. So essentially you have pressure, but you have no gallonage or GPM behind it. Basically it's hollow. Well, you can have the same thing with electrical. If you have voltage present, that is the pressure. But unless the valve is open and it's being allowed to flow, there is no current. So when it comes to which one of those, one of the things I usually tell people is think of it kind of like a river. When we're talking about pressure or voltage, it's the fact that there's water there and the weight that it applies. But what makes it a river is the current flowing downstream. That's what makes the system work. So when it comes to amperage, just think current. We're talking about the actual flow. What the ammeter does is gives you a visual of those electrons flowing. So the ammeter is a flow meter. Voltmeter, it tells you that there is pressure or voltage there. So it's the two different halves. So when we talk about water, we have a pressure gauge, but then we teach you how to calculate GPM. And if you know how to talk nicely to the foam pro system, it will actually tell you what gallons you're flowing out of anything that has foam applied to it. So we have the ability to do it that way with those components as well. So when we're looking at this list, batteries store the power. Alternator creates the power to refill the batteries. The voltmeter gives you a visual of the voltage or pressure. The ammeter shows you whether or not it's flowing or not. The load manager is a system that was invented to help you prioritize what you've got turned on and what you're willing to get rid of if for some reason your batteries aren't keeping up. So all the power for your vehicle comes from the batteries. The alternator's job is to supply what power it can and refill those batteries. Questions? Cool. All right, so when we talk about batteries, there's a bunch of different kinds, there's a bunch of different colors, but one of the things to keep in mind is that there's actually only, I think, 3 battery manufacturers in the United States. But how many different battery brands are there? Hundreds. Hundreds. We have maintainable or maintenance batteries. They have caps. We have maintenance-free batteries. Those do not have visible caps. Why do we care? Well, if you're somebody that's really into taking care of your vehicle, you might want to spend a little less money, buy a maintainable battery, and then you can actually check the water in your battery every once in a while. If you're one of the people that doesn't ever mess around with it, doesn't even know how to pop the hood on your car, you might want to go with a maintenance-free. Difference here, I can make this one last a lot longer because I can make sure that if there's any inadequacies in the fluid levels, I can put them back. This one over here, it's like an idiot light on the dash. It works until it doesn't. And when it doesn't, you don't go anywhere. You call AAA or whomever is going to provide you a battery, and you are completely at their mercy. I have a lot of time out in the desert. These batteries do not survive too well because it's very arid. That electrolyte fluid, the acid and water inside that battery has a tendency to evaporate. These die quick out in the desert. These you can add water to and get the full life out of them. So most of us in arid climates actually preferred maintainable batteries, and they were cheaper. Questions?
Is there a certain type of water that's in there, or is it just normal?
That's actually a good question. Purified. If you look at the letter of the law, how they actually want those things done, they actually want distilled water. The idea behind it, they don't want any bacteria growth inside that battery. By going with heavily filtered water, the reason they do that is because they don't want you adding a bunch of minerals in there that are going to actually build up and create Carlsbad caverns inside your battery. Why is it important with that type of battery to keep the fluid level up? If you expose the lead plates on the inside, now you've got something that's designed to be submerged, exposed to the air. The acid will crystallize. So what makes the voltage or the actual electron build inside those batteries? The difference between one plate to another. The electrons are trying to even out. The lead acid itself is what makes the electricity. What causes it to flow, what allows it to regenerate, is the fact that those plates don't touch. If you let the water level evaporate down, that acid will dry out. It will create a mechanical bridge from one plate to the next, and now those portions of those plates will no longer produce power. They're now one. So do you understand what I'm talking about by the electrons? It's kind of complicated, but it's actually not. Mother Nature does not like imbalances. You will hear me say that at several points during this lecture. The idea, if you have a molecule that is positively charged, and then you have one right next to it that is negatively charged. The two are going to try and balance out. So one will actually give to the other to make sure that those things balance. If I continue to pull it off of the end by taking current out of this battery, those electrons just keep bouncing across and making more electrons. That's the actual current flow. So a battery does nothing more than that. If those plates are in contact with each other, that flow doesn't work right anymore because now there is no difference from one to the next. It's built a bridge and now it's ineffective. So you don't ever want to let the water level in a battery drop too low or you're going to damage it. And unless you can figure out a way to get that lid off and pick all that crap out of there, it's done. Believe me, you do not want to open a battery. That is Pandora's box. They'll have corrosive acid everywhere. Any idea what kind of acid's in there? Sulfuric. Now, these are what our gels look like. Any of you off-roaders? Really? That's kind of surprising. There's this thing with firefighters and off-roading and big Ford trucks. I don't know what it is.
You can't afford it yet.
All right, that's a good answer. I can use that one. I understand that. The reason I bring this up is because gel batteries are the weapon of choice for most of your off-roaders, because if you roll the thing over, you don't want that lead acid or that acid solution leaking out. So they switched over to using gel batteries a long time ago. The nice thing about it, you don't have the off-gassing from that acid solution. That off-gassing causes this. Causes that corrosion to take place. Our lead acid batteries have always had that problem. It is just the nature of the beast. Now, our gel batteries, we do not. They always, whoops, told you, I'm more likely to eat it. This is what they always look like. As part of our traditional procedures, your task book for your triple combo, I believe, still mentions, you need to check the batteries and make sure that the connections are clean. If you find a dirty connection on a gel battery, something else is going on because they don't leak that way. There's no cleaning. Never mind the fact that as we go through this, one of the things I want you to understand is I do not want you disconnecting these batteries. On the old rigs, I told you, 1,000 years ago when I became a firefighter, this was a normal monthly thing we had to do. And you could take all those connections off. Why? There were no computers. You put the connections back on and all the stupid things that have wires and switches still worked. Computers don't like it when you just yank the power from them. They have a tendency to lose all their programming. Bad idea. So there's literally one of your 6 batteries on our modern vehicles is hooked up separate. The idea behind it, they didn't want the charge and discharge and the voltage spikes. So when we turn on our code lights, it puts a tremendous strain on our voltage. Our batteries are getting kicked pretty hard. They realized that that was actually causing a brownout condition for our computers. So they have one battery. One of your 6 batteries is set off to the side. It's not wired in with all the rest of it, and it has its own charging. They want that one for all the memory for your computers. If you mistakenly disconnect that solo battery, you'll lose all the programming for the MPC, for all of the injection systems, all the rest of it. Bad day. We don't want to do that. So switching over to the gel batteries has actually worked out very well because now you don't have to worry about that programming being lost anymore. Questions? Cool. All right, so the alternator. What does the alternator do? It's our power plant. It's our generator. They used to be called generators, and it was easier for people to understand the term generator because we all know what a generator does. It makes electricity. The difference between an electric motor and a generator. An electric motor uses power. A generator makes power, but it's the same machine. How could it be the same machine? Well, if you look at an electric motor, it's set up so that I can actually turn on a switch from a power supply. It will use the current that I'm giving it and it will spin. If I disconnect that power supply from it and I hook that same electric motor to a motor, gasoline engine, something along those lines, and I spin that electric motor, it now makes electricity. I'll use those same connections and I can hook them up and they'll go do other things. The difference here is, do I want it to use power and do something else for me, or do I want it to make power and do something else for me? Copy that? All right. So, an alternator is nothing more than a modern version of a generator. It has the ability to control itself. It can kick on, kick off. It can adjust its own voltage levels. Where before, a generator, you wanted more power, you had to spin it faster. If it was loading down, if you didn't get enough power out of it, you had to spin it faster still. An alternator has components built into it that will allow it to adjust the amount of power it puts out by need, even at idle. They don't cool real well at idle, but it will adjust. All right? So the difference between an alternator and a generator, because they still make generators and they still make vehicles that have generators on them, and if you've got an old Volkswagen, you have a generator. You had to spin those at a certain speed for them to do anything at all, where an alternator charges all the time. So, the alternator provides electricity for the batteries, the starter, the fuel injection, the lighting, the warning lights, the secondary braking devices, and all portable battery chargers. Here's a term for you. Do we know what a parasite is? In any form.
Drains the system.
Any system. It's one of those things, if it's a bug and it's attached to a tree, it's literally sapping off the tree. It's living off of another thing. We have a concept in the automotive world called a parasitic load. Parasitic load is anything that is constantly pulling crap off of your batteries. Can you think of stuff on our vehicles that are constantly pulling stuff off our batteries? Give me one.
MDC.
Beautiful, tick, what else? How about every goddamn thing we have plugged in? Everything, they're everywhere. So, something changed. I don't know if you guys have realized this. Now, if you have a flashlight that has alkaline batteries in it, what happens if you don't change those batteries every once in a while?
Corrodes the connections.
Beautiful, why does that happen? We talked about it with the lead acid batteries.
Because off gassing.
Outstanding. When I was a kid, that didn't happen. Your alkaline batteries could go completely dead, and that did not happen. In the early 90s, we started to see a little bit of that. In the mid-90s, it went wild, rampant. The reason, and actually I just recently found this one out, did the whole Google. Why do these batteries keep destroying all my flashlights? Because in the mid-90s, the EPA changed regulations. They had to take all of the heavy metals out of those alkaline batteries. And because of that, they had to replace it with something else. That something else off gases. So as the battery gets used up, gets to a low level, that off gassing is dramatically greater and greater and greater. It's trapped inside your device. As you go along, if you don't change out modern alkaline batteries, it will destroy everything you put them in. So rechargeables have become even more enticing because the alkaline was always the better battery to have. Unfortunately now, they are, I would consider those things almost like a parasite. They destroy and eat whatever you put them in. All right. So when we talk about parasitic loads, what I mean by that is all the flashlights, the MDCs, all the chargers, everything we've got on there. Now, when you plug your shore power, that ejectable cord into the side, I don't know if many of you realize this or not, but that's actually controlling the little air compressor that keeps your air tanks up if you have a leak. But it has its own wiring. If you open up the engineer's compartment and you look at that upper half where we store all the crap that never gets used, okay? In there, you literally have an outlet that looks like one of these on the wall. The reason it has to look like one of these outlets on the wall is because it literally is an extension of the cord you just put in. It is not your vehicle wiring. It is a 120 volt system that runs off that cord separate from everything else and goes into that compartment to charge whatever you need charged. So that little air compressor is plugged into it. Your battery charger for your vehicle is plugged into it. And it's completely separate from everything else. It's put there to help you overcome all these parasitic loads that are constantly drawing off your batteries, keeping your MBC up and all the rest of that kind of thing. Questions about that? That's why it's important to keep that damn cord plugged in. Because if you don't, there's enough stuff drawn off those batteries that within a couple hours' time, you may not be able to start the vehicle if you don't keep it plugged in. All right, so here's that picture again that I showed you. The alternator and the AC compressor. Now, I bring this up because the alternator and the AC compressor don't look all that different. And if you don't know what you're looking for, it is very likely that you will confuse the two. That's okay. Like I said, I'm not trying to make you folks mechanics. What I am trying to do, though, is get you to at least understand some of the different systems that are there. The alternator has a cooling fan right there on the front of it. Why would it need a cooling fan? Because anything that moves generates heat. Make sense? The AC compressor does not. It has this weird thing with wires that go to it. Remember that clutch I made mention of a little bit earlier? The AC compressor, you need turning at all times. Or excuse me, the alternator, you need turning at all times. That's what's creating your power. Your AC compressor, the belt is running. The pulley is turning, but the pump is not. The pump is not creating any pressure in your AC system until I throw that switch inside the cap and I say, let's make some cold. If the pressure inside the system is adequate, that clutch will energize. It'll take some of my 12-volt power. It energizes an electromagnet. We good with what an electromagnet is? Cool. That electromagnet grabs a hold of that pulley and starts turning the compressor. Yes?
Is this picture a view from underneath or when the hood is?
From the side. I am standing in the wheel well right now on the captain's side. Front captain's side. Got me? The red thing right there is the frame. So, you're supposed to check belt tension. What I want you to understand here is that this check is to be done with the engine turned off. Here's the thing I want you to understand on this. The old days, these were all manually adjusted. The current systems are automatic. They use a single belt, what they call a serpentine belt. Serpentine because of its configuration, not because that's what the belt is actually called, because of how it's being used. Some of the pulleys are grooved, some of the pulleys are smooth. The ones that are grooved are working off the inside of the belt. The ones that are smooth are running off the outside of the belt. Now, do any of you actually know what an old V-belt looks like? No?
Yeah.
Yes?
Yeah.
Oh, it's going to be you all day, isn't it?
Oh yeah.
All right, so let me give you a side view of it, or should I say a cross-section. The old V-belts were somewhat arch-shaped on the top, came down, had a smaller bottom than top. It was a self-tensioning, if you want to consider it that way, belt. All the pulleys that it ran through were matched to fit that shape. As the belt wore, it just slid further down into the groove and maintained traction. So it was called a V-belt because it was built to run in pulleys that were V-shaped. It was auto-adjusting because as it wore down on the sides, so it would fit into the pulley here. So your pulley was shaped like this. Of course, never failed. So your pulley was shaped like this. As the belt wore, it just slid further down in. Over time, they would become slack because it now rode in a pulley in a different place than it used to. And you actually had to go through and actually check these for tension. So the way we did that was, again with the engine off, because remember, the group, there's that guy. You would go to the longest free span, either this one, and it was not supposed to have more than what they called a ½ inch of deflection. Meant if you put reasonable pressure on there, it shouldn't be able to be pulled more than a ½ inch. You don't even need to worry about that on the modern vehicles. The reason I bring it up is because not everything has serpentine belts on it. Some of our older stuff does not. Some of them, the accessories that we put on the engines, are driven by a solo belt. You still need to check that with the engine on. So you're just going to put pressure right there on that longest span and see if you can adjust it. Now, when you look at these things, now there's this thing they call a tensioner, or what is commonly known as an idler or tensioner. The idea there is they're pulleys that don't do anything other than change direction. One of those pulleys has a big spring on it and an arm. And that spring is constantly keeping that belt at the same tension. They work very well, and these things last a long time, and they are definitely much less maintenance. Now, we're going to start looking into the things that allow you to see the stuff that can't be seen. Right here, we have the voltmeter. That's the one that allows you to see the electrical voltage or the pressure your system has. This, fuel gauge, this, front air, this, rear air. We're talking about electrical, but when we talk about your air gauges, which one is the primary and which one is the secondary? Do you know? Okay, the reason the rear is the primary, they figured out a long time ago. So the idea here, if you lose your rear brakes, you have nothing but front. You get on the brakes too hard, your rig's going to go into a spin. You will lose the ability to steer and keep that vehicle in a straight line. You're going to go into a spin. So they've actually redesigned air brake systems now so that it will sacrifice the front brakes and divert the air to the rear brakes so that when you are making your final, I think we're screwed braking, it's in the back and it keeps your vehicle straight. So the rear is always the priority. It fills first and it dies last. Why don't you write that down, because those are pearls of wisdom right there. All right, voltmeter. The voltmeter's job is to give you a glimpse of what your system is currently doing. If the vehicle is not running, that voltmeter is going to tell you how much voltage is available average across all of your batteries. If the vehicle is running, it's telling you whether or not the alternator is putting out and at what level. So if the alternator is putting out and my voltage is still low, it means it's putting a ton of power somewhere, either by recharging my batteries or keeping all my code lights on, making sure that all those parasitic loads are charged up. When we first start a vehicle, it is putting a tremendous strain on the batteries, the starter, all the wiring, and that alternator, because it's trying to balance out. While we're starting the vehicle, it's pulling a tremendous amount of power out of the batteries. Why is the alternator not helping?
Because it's not spinning.
The engine is not running. It's not providing power to that alternator. As soon as that engine starts, that alternator says, okay, I got a job to do, I can handle this. And it starts providing power. But it's trying to do everything all at once. Especially if we're the people that the second that engine starts, I'm on the code lights, the boss is hitting the growler, we're out of the barn. Oh man, that is a huge amount of power that's being used, because what should be going back into the batteries to replace the fact that I just started the engine is not. It's being sent to the code lights, the growler, the MDC, the headlights, the Telma, all these things that use power. Does that make sense? So if you have a driver that understands all of these things, there's kind of and I know, you've got this awesome ringing alarm you're going to over the 35s that you have to get to immediately. And you're pissed because the engineer is taking too damn long to get out of the barn. This guy takes forever to get that cord off. He can't get his butt in the seat in a timely fashion. For God's sake, will you start the rig and let's go? Don't care. Don't care. I'm not deliberately slow for those reasons. I'm deliberately slow because I make sure that I don't screw something up that's going to cause us to get halfway to the call and break down. Disconnect the cord. Why? Have any idea how many fires I've been on where you can walk past at least one rig and it's got a cord dangling off the side of it? Because they got so jacked up on adrenaline that they didn't even disconnect the cord. Do you have any idea why that little section on the end of the cord, about you long, is there? It's a breakaway. Why has that happened? Why do we put the breakaways on there? Because they have driven off and yanked the power cord off the ceiling time and time again. So that little chunk of cord that's on the end of that drop power, the shore power cord, is because we got tired of replacing all the power drops that come from the ceiling. That's why those things are there. Why do those keep getting disconnected and torn apart? Because you guys lose your mind when that bell goes off. Don't. Settle down. Panic is contagious. You're actually a better firefighter if you can think. All right, questions about the voltmeter?
I got a question just about the shoreline.
Yes, sir.
I've seen, some people will manually pull it out, and some people will let it automatically kick out. Is there a preference?
That's
or
a great
which
question.
which one's right?
The manufacturer says, please leave the cord in and let it eject under its own power. Are you a gun person?
Yeah.
Okay, do you know what dry firing is?
Mhm.
You're doing the same thing.
Gotcha.
Now here's the other side of it though. Kuzma, the manufacturer of our auto ejectors, will tell you that's gonna break eventually. No matter what you do, that's gonna break eventually. It's meant to be a consumable, it's a maintenance thing. So at some point, that little plastic ejector pin is going to break, and they know that. It's designed to be something they can pull apart and replace that pin and put you back down the road, rather than putting a steel one in, which is what they originally came with. When that was broken, you were done. Questions about that? Good question. Good question. Now, please hit the button. The reason I tell you to do that is because that is an option, and that was one of those things that worked out well for us. When it ejects, okay, we were talking about electrical pressure, voltage, and flow, current. Those electrons are trying to flow. While it's ejecting, it's still making contact as those two plates from the plug and from the male end of it that are on the vehicle. As they're sliding apart, current is still flowing. As they're getting closer and closer to the tip, now there's almost nothing touching anymore, but current is still flowing. As they let go of each other, current is arcing across the gap. It's called lightning, by the way. And as it gets further and further apart, that arc will continue until it physically cannot bridge the gap anymore. Once they're no longer touching, that lightning bolt bridging across there is melting a hole in those two blades. It's burning it, leaving carbon deposits and destroying, pitting those two blades. So if you turn that box off and let it eject, the Kuzma will last the longest and do the least amount of damage to your connections. If you forget, you forget. It's not like it's the end of the world. You can't fix those. But if you turn the switch off and let it eject on its own, both those components will last as long as they possibly can. Great question. Any others? If your voltage, let me go back on this one here. Let's see if we can get that one back. A reading below 12.6 indicates that one or more of your batteries needs charging, or that there are abnormal loads. Now that is after the vehicle starts. So when we're looking at this picture right here, I hate current gauges. I hate the way our gauges are set up. I know hate is a bad word and I'm not supposed to use that anymore, but if you look at a gauge and it's only got a few measurements on it, you got to figure out what the difference is between the two. So right here, we have 12 volts there. We have 14 volts there. What's the span between the two? The span between the two is 2 volts. So the center one right there is 1 volt different from 12 and 14. What is the voltage reading as you see it right now? 13-ish. Yeah, 13-ish. These things are about as accurate as a hand grenade. They're not very accurate at all. And they'll vary dramatically from one rig to the next. And they're also temperature sensitive. They'll read different very cold than they will very hot. So these are not exactly an instrument, we'll say. It's a bit more like, it's about as precise as a sledgehammer. So this is about 13. Also, when you're doing your pre-trip, those of you that have been looking at your coals, how many pounds of pressure am I allowed to lose in 1 minute on an applied brake inspection? I heard it.
3 PSI.
3. What the hell does 3 look like on a gauge like that? You can't read it. The only thing you can really tell me is if it dropped while you were applied. That's really all you can do. Here's the other part of it. If I have a combination vehicle or more than 2 axles, how many pounds of pressure am I allowed to lose on 1 minute? 4. The hell does 4 look like on that gauge? How am I supposed to tell the difference between 3 or 4? Pressure gauges back in the Stone Age were about that big, and they literally had numbers printed on it. It was amazing. Now everybody's all idiot-like. All right, so voltmeter. When we're looking at this thing right here, we're giving you readings of an idea. 12.6 volts. What does 12.6 volts look like? That's kind of like right over there. Making sense? I don't expect you to tell me exactly what that is. So when I put a slide up like this that says, If your voltage without the vehicle running, just looking at the battery voltage, is 12.6. Just average, somewhere between 12 and 13. If you start the vehicle and the voltage stays low like that, we got an issue. Either it's trying to restore a very, very low system, which is possible. You guys didn't plug it in like you were supposed to. It's very possible these batteries are down low. But you should start seeing over a minute or two where it starts climbing back up again. If it doesn't, we got a problem. That's what this slide's about. So, if you have a problem with the voltage not climbing once the vehicle starts, this is one of those things that is not necessarily the end of the world, but it's something you need to watch. If you turn the code lights on and the voltage drops even lower, you may have lost your alternator. You may have a couple of bad batteries that are sucking up all the power and they're not refilling. All stuff you need to call the shop about. All right, so with the engine running, what normal looks like is somewhere between 13 and 14.8. Questions about that? Technically speaking, an alternator can actually achieve up to about 15.2. We have our regulators set a little bit lower than that because batteries, especially the gel ones, don't like getting overcharged too much. So we've got ours set a little lower. So between 13 and 14.8 is about where we would like to see that voltage while the engine's running, if the batteries were kept up. And with anything else, as you're going through this, if it doesn't look right, just call the shop. They would really prefer that you call them up and say, this is what I'm seeing. With the new phones, everybody's got phones. The department gives us a couple of phones now. Either take a quick video or take pictures of it and email it to them. They love that stuff because then they are absolutely on the same page with you. Okay, the guy's looking at the gauge that he told me he was looking at. It's reading what he told me it was reading. He's described turning stuff on and turning stuff off and the fact that it doesn't change. How? Because he sent me a little video that showed me actually doing those things. The mechanics love that because they get a great idea of what's going on. If you call them up and say, I'm going to send you a video, I don't know what's going on, I don't know what this gauge does, all I know is a red light came on when I was driving it and I don't know why. You send them a real quick picture of it or you send them a quick video of it, they look at that and they go, I know what that is. I know what it's doing. I know why it's happening. Let me call this kid back and let me tell him what to do. Or park the rig right now. We're done. We're done. Anybody know that your dash lights are actually color-coded? Stop lights are traffic lights. What are the colors for our traffic lights?
Red, green.
What do they mean?
Red stop, amber you can make it, green stop.
Amber, you can make it? On video, you just told me amber means you can make it. What does amber really mean?
It means you should slow down and stop.
It means that you're on your way to stopping. Okay. Don't do that on your drive test, man. Don't.
Okay.
Beth is very, very specific about that. She would like you to start slowing when it turns yellow. Accelerating is not going to go well for you. Your dash lights are actually color-coded the same way. If you turn on your vehicle, you power up your dash, and a light comes on that is green, that says conditions normal, it's just telling you it's on. If a yellow light comes on, it's telling you caution. Something has changed. If that yellow light is constantly on, it is a low-level issue. If that yellow light starts to flash, it has escalated or changed condition. If that yellow light goes out or stays on and has a red one come on next to it, things are bad. Usually when the red one comes on, it says, stop engine now. They're really kind of not kidding about that. That's a bad situation. That means that either you've lost oil pressure or something is cooking, one or the other. It's usually either an overheat or a loss of oil pressure situation. Engine 15 had that happen. So if that happened in one of our newer rigs, an O-ring blew in the oil delivery line. They lost oil pressure. That engine was smoked. They ended up having to replace the crank, all the bearings, the oiling system. Not a cheap thing. Luckily, under warranty. Not supposed to happen. Shouldn't have happened on a fairly new vehicle. So when that red light came on, that was no joke. That was an expensive situation. So your dash lights are color-coded, and they can tell you when situations are changing or escalating. But you got to pay attention. This is the ammeter. The idea behind the ammeter is it tells you whether or not you have current flowing. Is it flowing in a good way? Is it flowing in a bad way? Here's what you're looking at. This is like a flow meter, and it has a positive and a negative. When you're starting the vehicle, this needle is going to drop onto the negative side. Why would it drop onto the negative side while I'm starting the vehicle? Drawing without replacing. Making sense? So we have current flowing, but it is purely coming out of the batteries. It is not being matched or replaced at all by the alternator. Kind of makes sense, doesn't it? Good. It's supposed to. This is not mysterious. It's all basic physics. So once the vehicle starts, within a second or two, I want to see this needle go from the negative side back up to neutral. Then I want to see it continue to climb and go back up to positive. The reason I want it to come up to positive is because I want to see that the alternator has kicked in, and that I'm starting to see that I'm creating electricity and I'm putting it back into those batteries at a rate faster than I'm using it. If I get into that rig, and you little primates are in the back seat and you're nagging at me about getting out of the barn so I can beat Poway to their lame structure fire, and I turn on all the lights, and I'm driving like a wild man, the Telma is one of the largest draws of power that vehicle can have. So I leave that Telma on. I leave the Telma on because if something happens and I got to stop this vehicle very quickly, I need that thing turned on. Is it possible to turn the Telma off completely? No, because it's still hooked up to my brake pedal. So even if I turn that little wand off, when I apply the brakes, that Telma still comes on. And it will come on at full strength, according to how much I apply the brake pedal. If you look at that ammeter and you look at your voltmeter when you're bringing the vehicle to a stop, the speed of the engine slows down because I'm no longer accelerating, which means the current is not being generated at the same rate it was on. And that Telma is using a ton of power. So all of a sudden you're going to start seeing this gauge go way down. It's probably even going to drop into the negative for a little bit. Until I get off that Telma, generator can catch back up, or alternator, excuse me, and we're starting to create power again. Making sense? None of this stuff should be magic, yes.
Where is the ammeter on the, it's not on the dash?
They're in different places depending on the, yes they are actually. They're in different places on different vehicles.
Okay.
But they are well marked. All right. Node manager. Load manager is kind of an important thing. It's a new invention. They first started coming out back in the early 90s, and they were like magic. So an engineer's job used to be to maintain a certain battery voltage. You did that manually. If you noticed that your voltage was starting to drop off, it was your job to get your butt in the cab and start turning things off. Somebody invented this computerized box, and it was obviously full of little wizards. Because we didn't understand what else was going on. We're firefighters. We didn't do this stuff. Inside that box essentially was a microcomputer designed to watch loads. That's all it did. So it had fingers in all of our different circuits. And all it did was watch voltage. And you could program this thing. And you could tell it, hey, if the voltage gets to this level, I want you to turn off this and this and this. But leave these things on. And you could choose. It was purely programmable. It would turn off things like your scene lights. The load manager's job is to do what you told it to do when you told it to do it. It's triggered by whatever your battery voltage is. And it will shed or shut off whatever things you've told it are important. Let me rephrase. It will leave on the things you've told it are really important. It will get rid of the things that it does not have on that list. It's what they call a shed list. The idea behind it, if for some reason your alternator is not able to keep up, because these things are so heavily laden with computer monitors and circuits and modules and you name it, it's going to do what it can to get rid of things like turning lights off and keep stuff within the limits it needs to be to keep the computers online. Now, in the old days, when you had a pumper and something broke. There was almost always more than one way to get things done. I had an engineer that I used to work with out in the desert that I have modeled the second half of my career after. He was an ASE certified mechanic before he became a firefighter, but he never lost those abilities. The dude was phenomenal. I'll even say it on video. His name was Tom Tomko. Dude was amazing. Here's how the guy was. We're on a structure, or actually on a vehicle fire out in the middle of the desert. It's a motor home, catches fire out in the middle of nowhere. We have a 1,000-gallon water tank on our rigs. As we're driving in, we're rolling up on scene, I hear the guy go, oh shit. I look at him, you good? He says, go, you're fine. Gets all of our lines charged, we're getting knocked down. I look back, cab doors are open, engine covers are open, there's a hose coming from the rig into the cab, and there's water going everywhere. I radio back to him, engine 61, you guys good? He's all, fine, just, you might want to hurry up. Okay. Guys, get it cooled off now. We get everything all done, we go back to the rig, and I'm like, what's going on here? He said, we blew a lower radiator hose just as we got here, and I'm using pump water going through the radiator to keep the engine from overheating while you guys do your lay. So we're losing some of the water from the tank through the radiator onto the ground while you guys are pumping. So you better get this mopped up soon. He identified what was wrong. He came up with a remedy very, very quickly. He implemented it without anybody else helping him, and he did his job while he was doing it all at the same time. Jeez. That's the kind of guy this dude was. I learned a ton from him. My job here is to hopefully get you guys on a path so that the people who want to be really good engineers have some place to start from. All right? All this stuff that's over here is giving you the tools to get you started. You don't have to become Tomko. Most people won't. But it's good to have somebody to start from. It's good to have a path to go down. And you definitely want to do what you can to be as informed and as in tune with your rig as you can be. If all else fails, there's alarms and lights that tell you, heads up. Just don't ignore them. All right, so big thing about the load manager. When it's doing its job, there's a little light on. It says load manager. There's a switch up above on the headboard switches. Just tells you that it's there and it's turned on. It can be turned off. Don't suggest you do that. If it's active, in other words, if it's shedding loads, it will come up on the command zone and it will tell you load manager active and it's shedding these things. That means something's wrong. It shouldn't need to do that. Something is wrong. You're going to need to call the shop. Even if your rig does not become disabled and you're able to complete your goal, you definitely need to call the shop and let them know. I don't know why, but the load manager started shedding loads while we were on this fire. They're going to do everything they can to ask you, what did you have on? What did it show? If it shows something like that, and you think to, grab your super cool iPhone-y thing and take a picture of the screen. Most of this data is actually stored. If you get into an accident, all the data about how fast you were going, whether the rig was leaning, how much brake pressure was applied, how much Telma was applied, all of that is actually recorded. So I beg you, if you get into an accident, tell the truth, because you're going to look foolish when they pull the data and find out that's not what you said. If you don't know, you don't know. But all that data is all recorded.